Okay, this recording is by Ben Klein, and I'm just going to discuss some of the techniques and examples that were gleaned from the ECE Teaching Scholars program, which specifically addressed teaching ECE 2036, the C++ programming course. Um, so the first thing that I wanted to mention was that in this class, we encourage the students to bring laptops to class, and I announce at the beginning of class that I'll be, coding on some topic, say if-else statements, and I will usually write code from scratch during class. Well, from scratch is a little bit misleading. I'll usually have a pre-written code that I'm looking at. But I'll start a fresh code and type it in as the students type along. And I've found this to be very popular with the students. Many of them do participate in program along. And I'll pause at certain points and ask them to tell me what I should do next. Or maybe enter in a line and ask, why did I enter that line in? Something like that. So I want it to be very much participatory class because I strongly believe that you learn coding by coding, not by hearing about coding. But beyond that general principle, one of the things that came up in the course of this Teaching Scholars program was identifying sub-goals in code and labeling them and using consistent labels. So for example, almost all C++ programs have some preprocessor directives, which you'll see I have labeled here as a preprocessor directive, that they will all have, for example, declaration of variables, which I label here as declaring variables. So what was emphasized over the course of the program was to use consistent labels so that the students sort of have something to latch on to. They can see the structure right away, even when they're starting out. Another technique that I used after completing that program was trying to incorporate more active learning. Of course, they are coding along with me in every lecture, but kicking it up another notch is having them write code during a lecture without without copying me. So I issued 3 coding challenges, which through the course of the semester, where they essentially broke into small groups and worked on a coding challenge during the class period. It usually occupied most of the class period. I found you had to give it a certain amount of grading weight, otherwise a lot of students would just spend time on Facebook. So I had them upload their results to T-Square's Dropbox, and I gave them a small participation grade for participating. I didn't really grade their submissions in detail for correctness. I just wanted to see that they had given it a shot. Some teams obviously finished very early and were told to break up and kind of disperse amongst the other teams to help them out. So I'll give you a quick example of kind of a grading challenge here. The third grading challenge of the semester involved inheritance and polymorphism. So I told them that they had to achieve a certain output and from a code. So I wanted them to achieve this output, and I gave them a code, a base code, which was this, and told them they could modify the classes, Class A, Class B, Class C, as they saw fit. They could not change the main function. And they had to modify these classes in order to obtain this output. So with one caveat, they're not allowed to just have a function y. In other words, C's func1, I couldn't go into func1 of C and have it say it's A's func1. So a function can't lie about what it is. But other than that, everything is fair game. So the purpose of this was to have them realize which version of these functions was going to be called in what circumstances. If it's being called from a base pointer, if it's being called from various other things, and and to set the functions to be virtual, for example, would be one thing they would have to do. Set certain functions to be virtual, or in some cases you could even have a function call another function. So I could have this function call A's func1. And they enjoyed this challenge. It was a nice way to get them to really understand inheritance and polymorphism, which is typically a challenging subject, I think is fair to say. And I'm happy to share these documents with anyone who's interested. Another tip and technique. There were some comments that there was a feeling that the class kind of has three components: the in-class programming, the exams, and the projects. There are typically 6 programming projects, and there was a feeling that maybe these are not tied together well enough, that they felt that the material they were learning had no relation to a project or to the exam problems. So to really try to tie into the exams better, I gave quizzes, and quizzes I use really very loosely here because these were not graded. Quizzes in order to that consisted of problems very similar to the exam problems. So for example, here was a Kahoot quiz where they were given this code and they were told to figure out what the output of this code is, which is a very typical exam problem for me. This is a case where we are passing variables by value, by reference, by pointer, and so this is really the meat of this, is understanding what happens when you pass in these various ways. So I gave them this code before class via T-square, and then very shortly before class, and then during class I gave them this quiz. Let's see how to play this, where they had to let's see, let me start it, where they had to determine what the output was. So I gave them some different options here. I'll just go back. They gave them these options as to what the output was. And it's a poll, so they enter on their device which choice they think is correct. Typically they're wrong, in a pretty high, only maybe a quarter of the students is correct when I initially give this quiz. Then I give them 10 minutes to discuss amongst themselves about what the output should be. And I re-administer the same question, and typically it's 100% at that point, have it correct. So yeah, I think they get a good experience of the kind of problem that they'll see on exam, and hopefully in their discussions with their fellow students get a feeling of how to think about it. And then afterwards we discuss briefly why the correct answer is correct. So lastly, just to mention, it is important to keep the project synced to what's being taught in class. So we do that typically by we coordinate the projects amongst the 2 instructors or 3 instructors, and we just have to discuss amongst ourselves before they're assigned to make sure that it correlates to what's being taught in class. So that's all I have. Thank you very much.